Yep, so now let's jump to regression. Just as a quick reminder, regression is when we are not really dealing with any geometry, but we have certain input conditions, numbers, and usually these numbers go into a model that takes a lot of time to get these output outs. And I'm going to again show with a simple example here. Um, the key idea was for me to show how easy it is to get started with machine learning and also how you can use synera. So I would like to first start again with importing a CAD, that workflow that I already built. So this is basically like a bicycle tube or like a AM. AM. And what this is basically I can vary my radiuses and just get these CAD out. And how it works in the background is I have this logic to create this CAD geometry based on also some parametric values. Um, Using everything, this thing is basically constructed entirely in Synera, this whole CAD geometry. And what I want to be able to do is my problem definition is going to be simple. I'm just going to constrain one side, apply forces on the other side, and measure stress, displacement, and maybe I guess mass. Uh, and then we see how we can do regression tasks inside Synera. Okay, so let's start. So I have my CAD now, and what I would need is basically first let me put these into some containers. So this is a mid surface. I'll just put it into a body container, and let me put the boundary surfaces for meshing, like a mid mesh into a surface container. And the reason I use containers personally is it helps me to visually check if something is coming in and going out. And now what I want to do is construct a FE model out of this. And for simulation engineers, this is also quite straightforward and repetitive. You need to always mesh it, define boundary conditions, apply the force and things like that. And I want to show you a huge value that our users have. They just copy paste from different workflows, something that they already did. It's just 1 second you get it out, and I can just plug these things into surface body. This will be my support surface, and then the circle will be my curves. And what this is doing is basically it's taking the body. I use hypermesh to mesh it. I basically declare it as a shell part. I apply some fixed displacement. I also can build my RBEs, apply the forces, do a linear static step, and construct this model. Basically build the load step. And so therefore I'm just also going to take some parametric values here, and I don't need them to. Okay. So basically this will be my thickness, and this will be my force value because I'm giving it in minus Z. And once I plug it in, it takes in everything, every input, and should be able to give me out a model already. So let me just turn this on. So I just plug the geometry in, and I get my shell mesh out. I apply my forces applied, and I also get my boundary condition. And now let's say if I change the CAD model here, it will automatically go through the same sequence of process, and I don't have to worry a lot. So if I just wait for a couple of seconds, basically I get my model out. And this is extremely valuable for also for simulation engineers and for data engineers, or for going to machine learning tasks. This is very useful because you can build data sets super quickly. Okay, so now that I have my shell mesh model and things out, basically I want to be able to just solve it. That's it. And I'm going to use here my OptiStruct solver, and then just plug my model in. Okay, and my model was successful. I can see that it's true. And now I need to post-process it to get some values out. So I also have a custom logic that I built to post-process. So I just need my model here, my load step here, and what it needs is the mass. And basically, I can get my displacement, stress, and mass out. And the way this works in background is I take the load step, I construct some responses, I evaluate these results, and just convert my mass from into tons. Yeah, so basically I just got it. Let me put it into number containers to have a visual representation. Number, and this is also a number. So that was it. And this is my, yeah, there's the displacement, stress, and mass. So now what I have here is a set of inputs, for example, the part thickness and force value, and I have some outputs, some numbers. So all of these are numbers, and I mean, in this example, in total, it just takes only 20 seconds, and this is for my live demonstration, but usually models can get complex, they run for hours, and we don't want to waste so much time waiting for some KPIs. And this process is same as last time. We have some parameters, we have some responses, we can easily build a data set. So I will go for design exploration again, and I will do a parameter setup here. Let me just go to my setup. I'll choose my parameters to be part thickness and force value, and my responses to be all these numbers. But let me just maybe rename them so it doesn't feel confusing. Okay, classic spelling mistakes. This one would be my stress, and this one would be my mass. So I have my three responses out, and now I can just, let me see if I have it right. Yes. And then I can quickly do design exploration. Again, I'm going to show you a simple demonstration here, maybe just run 10 of them. I do a random grid search, and what you can see is it already gave a set of random sample values, just trying to explore the design space, and I can already start evaluating them. So let me just see the yeah, maybe just get my model view out to make it visualizable. Okay, so just to keep this one as my visualizer and just to show how it works, let me hit on evaluate. And what it will now do is basically yeah, go through each of the parameters. Now you see for the first parameter, it's setting up FEA, it's solving, and then I will post-process them and get my outputs on. So I see for already for my first design sample, I computed my displacement, stress, and mass. In the same way, I will keep on computing them for other samples. Yeah, so that's how you can generate a data set. And now again, I would like to stop it, use something I have already prepared to save some time. So I did run 250 samples. It's a bit less for such applications, but again, I just want to show how you can do this. So now I have my samples, and in the same way like last time, these are just samples like raw design. I want to process them, do some processing to get them out. So I also prepared one for regression. Let me just see. This is a data set splitting, but I guess I just need this one. So yeah, so I can give it a set of designs, and what I will get is my feature data, my feature column names, which was my inputs, my label data, which is yeah, basically the responses, the displacement, max stress, and mass. And the way this works in the background is pretty simple. I deconstruct these designs, do some yeah, matrix operations, get these data set outs that I need for the next steps. And now I also need something. For this case, I decided, okay, yeah, basically I need such a working way to get these feature data and label data set. And now I can just plug these things in. So feature columns, feature column names, and this would be my label column name. And this will extract me all the relevant columns and then give me my feature data set and label data set. And again, it's simple to start with machine learning in Synera. Let me just go for a linear regression here. I drop it. This will be my feature data set, my label data set. I basically got all my three models out. Just as a background for linear regression, the way linear regression works is you can have multiple inputs, but you can only always predict one output. So this is how linear regression works, and that's why I had to do this operation to separate the label data sets out and get it as three different data sets. But now I have three models. And now what I can quickly do is again do a prediction. So let me go for model prediction. As you can see, it already there is also a simple AI that's working inside Synera that will predict my next nodes. And yeah, I will just copy a sample data I already prepared. So basically what I do is take my inputs in to predict the outputs out. And for column names, it should be the feature column names. Yes. And then I can plug this data set in. So I have a prediction out. Let me just deconstruct it back. And then basically what I have is if I flatten them out. Yeah. So basically this is my prediction. And let me just quickly also evaluate the accuracy for these. So I'll go to model performance. Yeah, true. Not here, but here. I also need my features here. My labels here. And then I can see my metrics. So you see it's almost at 84 to the R2 is like 0.8, 0.9. And this is because it's not, you can of course, if you increase the sample size, you can go more in, or if there is also different algorithms possible. Let's just change certain algorithms. I already see I have better R2 score now. And also, let's just also try the classical way, what the solution would be. So I will just go to 1.4 here. And I guess that was minus 201. And let's just see the values out. Yeah, 208, but I guess shouldn't matter much. Yeah, so this is how easy it is to basically build a simple reduced order model inside Synera. And now what I've experienced is sometimes, like I guess there was this interesting question, can I not build my own models? The real intention was how can I hyperparameter optimize? Yeah, and the way we can do this, we also have all possibility that you can take this data set out, use an external ROM builder or just Python script, build your model, export that model, and bring it back in. This is a bit too technical machine learning side for this session. So what I did was I took this data set out. So basically, this is a data set. I took it to a external ROM tool from SimCenter or Altair. You can use any of it, or also build your own Python script. And basically, what I did was I brought them back. So let me just the way you can export is very simple. You just use this export data set. You just give it a name, and then my data set would be basically my stack data set that I created here. Yeah, and this was the reason I created. So you can plug this in, plug the data set out, and you would have written a CSV now. And let me just show you where I have it. So you see, I just was able to write it quickly here. So I wrote it right now for all this as a CSV file. I can take the CSV file into any other tool I want, build a neural network or whatever model the finest way I want it. And if I just export it as an ONNX or FMU file, I can bring it back in. And so that's what I did. So I can also take a one FMU. Let me go to the file path, or better. So this is where my FMU is in, or yeah. So as you see here, it's something I created in Altair, and this is hyperparameter optimized it. Yeah, and basically what I have to do is just vary this input so I have my outputs out. And the reason I get it, yeah, I just need to list one of it out, and I can get those prediction out. And yeah, and let me just take some things I prepared already, so I can quickly plug in my things. And what it will do is basically run the FMU and basically get my outputs out. So yeah, there are these two ways how you can integrate machine learning inside Synera or your workflows. So you can either build simple models here, or you can go out, build a complex model, and easily import it back in. So it can be either FMU. You can also import your neural networks. So we also have something for that. So you can also just give a file path, your input layer name, output layer name, you get the model out, and from here it's same. You just plug it in as the predictor model, and then you can work around with this. So yeah, I've seen customers or engineers use both the way. There is pros and cons for both of it. As I mentioned, if it's a simple task, you want to just get it done, better to stick with Synera, get the value out easily. If you are someone who wants to be more control of the whole model, right now you can go out, build your model, and bring it back in and easily control it through Synera. Yeah, so that's how you can build also a simple or a regression reduced order model inside Synera.
I really appreciate it, Ron. Super insightful. I was wondering regarding the mesh sensitivity study, because you're training the model based on a random mesh, right? Would you do a mesh sensitivity study before you actually use it as training data, before you build the ROM, or
Yeah,
how would you approach this?
yeah, I think that's very important. I mean, I guess it depends on I would say the responses. Stress, of course, yes. Displacement, yes. I guess for model analysis, I'm not sure if it matters so much. I think it matters because there is the stiffness. So yeah,
Yeah.
I think I would always go for a mesh sensitivity analysis, get the right element size out, and then yeah, run the whole data set on it. So I think yeah, that's the right way to do it.
But I think it also is cool in Synera because you would be able to actually maybe run a number of experiments inside of Synera and then actually plot kind of
Exactly.
the degrees of freedom and the stress, for
Yeah,
example.
exactly. Yeah, you can also have your own plotting functionality. So yeah, exactly. So you can write a custom uh, sensitivity analysis logic, and then you can just maybe build a plot of some values, how this was spread, how did the values vary, and you can find the mesh sensitivity analysis out, the
Really cool.
ideal element size for you. Yeah.
Yeah, really cool, Ram. Any closing remarks from your side? I think I posted every relevant link in the chat, so people can check it out. 14 days, it's for free, as well as check
Yeah.
out the marketplace for some insights on what tools you might be connecting to Synera. Yeah, let us know in the comments what you think, and we'll be uploading this video on YouTube so you can rewatch it again. So no problem if you couldn't attend the session live today. Cool.
Yeah.
Ram,
Yeah.
any other closing remarks from your side?
Yeah, I think in general, AI is at a hype right now. So what my responsibility or what I usually tell engineers is to really look at the value, to really look at if there are some repetitive tasks, can I automate them? Can I use AI? I think that is more essential. So that's why I started also with a problem that is sensible to solve. And I'm also a huge a believer in don't use AI for the sake of using it. So I think the best way to start would be to really think at tasks that have this input-output relationship in a hard way, and then prepare a data set out and start. And I think Synera is a great place to start. We also have a lot of resources. You can quickly get your Synera knowledge, like the Academy. We also have a lot of documentation. So for example, each node will have its own help, so you don't need to start from scratch at all. So you can just copy paste them and yeah, start quickly. So if you're looking to explore machine learning, build some cool workflows, I think Synera is the best out there. And yeah, happy to have host this session, Jousef, along with you.
Absolutely. And if you want to get in touch with Ram, I'm going to post his LinkedIn link as well, so you can get in touch with him, ask him some questions if anything is unclear. Again, Ram, thank you so much. Hopefully there will be another session in the future. And we'll also launch a podcast in around 1 week, maybe next Sunday, next Monday, where Ram will talk about how to actually do assessment study or feasibility analysis of when you should use AI and when you should not use AI. So I hope this was useful to you guys, and I'll catch you in the next deep dive session. Cheers, Ram. Thanks again.
Thanks, everyone. Thanks, Jousef. Bye-bye.
Bye.